more solutions to the equation sine of, now it doesn't have to be theta, it could be x or whatever. Theta just means that's what I want to solve for, right? So I'm going to use x just so that you feel a bit more familiar with x and y's, right? So sine of an angle, which I'll call x, is equal to half. Now it says x is an element, so x is between 0 and 4 pi. Now remember, this is in terms of radians, and that's what x represents. X is the radian. So x could be pi and 6, could be pi and 4, could be pi and 2, could be pi, could be 2 pi. I don't know what x is, but I know it starts from 0 and finishes at 4 pi. Okay, so I'm going to draw a unit circle, and this is what I want you to understand. Unit circle, to make one revolution, okay, one revolution, according to this, the period of your function tells you how long it takes to make one cycle. That's what you learned in 14G, right? So if I asked you, what's the period of sine of x right now? What's the period equal to? What would you tell me? What would it be? N equals 1, yes, but what's the period then? 2 pi, okay, because we know that the period, to calculate the period, it was 2 pi divided by n, and in our case it's 2 pi on 1, which is 2 pi. So what does that mean? That just means that in order for you to go around the entire circle, starting at 0 radians, and you move all the way around for one cycle, it takes 2 pi. That's what it means, right? So now I'm just going to delete the blue section so that you don't get confused. We're just saying now that this is 2 pi. To go one whole revolution to get back to the same spot, this is now 2 pi distance. Yes? The 1, because n was the coefficient of x. Oh. Yeah, so from 14G, the number in front of x is the dilation factor that you're multiplying to x. Whatever that dilation factor is, that will affect your period. Okay, so it will be 2 pi divided by n, and currently the number in front of x is 1, so that's why it's 2 pi 1. Okay, so now we know the period, the entire circle makes 2 pi. That means halfway through from here to here, it would be half of 2 pi. Now half of 2 pi we know is pi. Okay, so we know this is pi here. And I'm just going to draw out that unit circle so you can see. I'm just labeling it so you can see. So I'm going from 0 to pi, and I know half of that would be pi and 2, and then therefore this is another pi and 2, makes it 3 pi and 2. Okay? Now that's starting at, remember I said x is just an angle. I don't know what the angle is, but I know it starts from 0 and it goes to 4 pi. Now so far I've only drawn up to 2 pi. So if I want to go to 4 pi, it would mean that I have to do another revolution. I'd have to go from 2 pi, I'd go over here, that's now 3 pi. Then I land back 4 pi. So technically I've done 2 revolutions. Okay, now that's key because you've got 2 revolutions, and the question is, what am I trying to solve for? They're asking, what angle will I have to do to get sine equal to half? Now let's go back to our understanding. What does sine represent again? Sine represents your y values. So what it's actually asking here is it's saying, when is y equal to half? So if you look at your axes right now, this is your vertical axis, that's your y-axis. You're asking when it's equal to half. Half is here. Because it's a unit circle, that's a distance of 1. Then half actually here. True? Okay, so if it's there, if this is 1, it's the height of 1, half is here. That's where sine equals half. So sine is, that's when half is. Then where around the circle would I have a coordinate where y equals half? Well, you think about it. The only 2 points that could give you a y coordinate of half around the circle is here. You can only be there, or you can only be here. You see what I'm trying to say? I'm trying to say, how can you have half as your height? That's the only point where you're going to have half as the height. This is the only other point where you're going to have the height of the triangle as half. Nowhere else. You can have half down here, but then there'll be negative half. You can have half down here, there'll be negative half as well. What we wanted was positive half. So now the question is, well, what's the angle that gives you that half? So what you're really asking is that radian. That distance on the outside is what you're asking. What's x here and what's x there? You see what I'm doing? I'm saying, what is this x length? What is this x length? That's what I'm trying to find. Now I've only done it from 0 to 2 pi, and I can already see I've got two solutions. I've got two possible angles. I've got this angle, I've got this angle, and if I continue, that's 2 pi. And from 2 pi, I continue again, I get another angle, and again another angle. That's why it's tricky. You see, it's very different to everything we've done. Every time we do quadratics, factorize, you get 2 answers. Did cubics, you get 3 answers. Did exponentials, you get 1 answer. You see, with circular functions, you can get infinite answers because it depends on how many cycles you do. The more cycles you do, the more solutions you get. That's why circular functions has always been harder to understand, and it's more about pitching than unit circle. So I'm going to start answering the question here. Here we go. How do I find x? We know that we need sine inverse of half. Okay, now because what do, I just did sine inverse of both sides, I did sine inverse of sine, cancels out, and I did sine inverse of half. Okay? The problem is there's going to be multiple answers. Sine inverse of half has a lot of answers. That's why I'm going to start writing here. So x equals to sine inverse of half. But how many answers can I potentially have? So let's look at my first solution. We said this is the first angle. Starting at 0. I'm going to do it in green so you can see. I started off at 0 and I move, and this is when I know I get a distance of half. So the question is, going back to your exact values, sine of what angle will give you a height of half? So think about it. Sine of what angle will give you a height of half? What was that, Lucy? 30 degrees, which is a radians is, what's in radians? 30 degrees as a radians. Pi over 6. Pi over 6. So I know if I had 30 degrees here, that's when I would have a height of half. And I also know it would have to be pi and 6 distance. So, since my domain is in terms of radians, I know the first one had to be 0, starting at 0, and I move pi and 6 distance on the outside. That will give me the first answer. So that's what I'm going to write. I'm going to write, okay, the first answer should have been 0, starting at 0, moving an extra pi and 6 distance. That's my first answer. Then my second answer is, what's the distance from here to here? Okay? That's your next goal. You want to know what is the distance from here to here. Now this looks harder to calculate. So what I'm going to do is I'm going to use the properties, symmetry properties from what I learned from 14F. If you know this is pi and 6 distance here, then that means you know this distance here has to also be pi and 6. If this is pi and 6, then what should the larger green part be? Yeah, 5 pi and 6. And that's what you guys were doing in exercise 14F. And I've been saying that was part of your homework that I wanted you to do, is because now that you know this is also pi and 6, this region here, I'm going to write it in green again. So this is pi and 6. Then naturally this makes sense that this is 5 pi and 6. Because you are starting at pi and you're moving back. Or you're losing pi and 6. That's what you were doing. Okay, so that will give me the same height because these two triangles are exactly the same. Okay, so this is my first two solutions. When I started at 0, if I move up by pi and 6, that will give me a height of half, and I know that's my first solution. So that's my one possible answer. So if I typed in the calculator sine of pi and 6, I should get half. If I did sine of now, if I worked out the other angle on this side, if I did sine of 5 pi and 6, it should also give me half. And then I finished at pi and I continued around the circle. I keep going around the circle, I'm still not getting any solutions, and I land back at 2 pi. But they told me to move from 0 to 4 pi, so I'm going to do another revolution. So here we go, starting at 2 pi, I go again, and I know from 2 pi I'm going to move up an extra pi and 6. So I'm going to write it down. I'm like, okay. Here's my third solution. Here's my possible third solution. I'd say starting at 2 pi, I'm moving an extra pi and 6. So starting at 2 pi, I move again and I hit. So from 2 pi, extra pi and 6. But then remember my last one is I got to go all the way to 4 pi. So I'm going to keep going and going and going. And then I hit my next solution. That's my fourth solution. And I can already see hitting here would be 3 pi. But at 3 pi, I'm losing an extra pi and 6 to get back. Okay? So that's why I know my last solution will now be 3 pi losing pi and 6. This is where it gets really tricky. So a lot of students will find it hard because there's so many solutions, possible solutions, and then you finish at 4 pi. So the idea is moving around the circle. I'll do more examples, but what I'm trying to introduce to you, the idea is that you start at one end, you find out where the points are, and the number of times you pass those points are the number of solutions you're going to get. Okay? So if I answer these questions now, if I simplify what I've just got, okay, so x should then equal to 0 plus pi and 6 is pi and 6. Pi minus pi and 6 is 5 pi and 6. 2 pi plus pi and 6 gives me now 13 pi and 6. And then 3 pi minus pi and 6 is now 17 pi and 6. If your fractions aren't good, I'll show you the way I do it. I do 6 times 2, which is 12. 12 plus 1 is 13. And I do 6 times 3, which is 18. 18 take away 1 is 17. It's all out of 6. So whatever the denominator is, that's what I'm doing. Okay, that's a quick way of calculating. So, what does this mean? So after you did all this, after this whole long step, what does that mean? You just found all the possible answers where x is not bigger than 4 pi, x is bigger than 0. Okay, so these are all the possible x's. If I actually sub every one of these into sine, it should equal to half. That's what I've calculated. I said, what are my possible solutions? Meaning, what are the possible answers? So that when I do sine of some angle, I get half. So we test that now. We go to our CAS, and I actually do that on my CAS. If I do sine, so I go to trig, on the side there, sine of, let's say, pi, where's my mouse? I do pi, I'll do the fraction first. I do pi on 6. There we go, we've got half. Now I'll try another one. The other part of our solution was, what did we have? We had 5 pi on 6. Okay, so I'm going to try it. I'm going to change this to 5 pi and 6, half. If I do the other one, our other answer was 13 pi and 6. So let's try that. Half. If I do another one, I tried 17 pi and 6. It's half. You see, what you're actually doing there is you're just solving all the possible angles as you move around the circle. How many times can you get the same height? Because as you move around the circle, the height goes up to 1, back to 0, back to 1, back to -1, then 0, 1. So how many times do you get back to half is what you're solving for. Okay? And the number of solutions will depend on what the domain is. That's why it's tricky. Okay? It's that picturing of how many times you move around the circle is the idea. How do we feel? It's meant to feel a bit overwhelming. Okay? And we're going to have 2 sessions on this. It's just more practice, the better we get at it. Okay? Let's try another one. I'll do another example so you feel a bit better. Let's try these. Okay, so if you don't like radians, this is a question where it's in degrees, but eventually you have to work all in radians. Okay, you have to work with the radians, which is the distance outside. So here we go. Let's do same thing, cos of theta, and I'm going to have cos of an angle. So I'm going to call it theta equals to √3 on 2, where I know that theta is between 0 degrees and 360 degrees. Okay? What does that mean? So if I draw my unit circle, first I question, how long does it take to make one cycle? So you look at the period. What's the period of this function? It's cos of theta. So what's the period equal to? What's my period right now? 2 pi. Because the value in front of theta is still 1. So it's 2 pi on 1, which is still 2 pi. So I know this is 2 pi. I know this is pi. And I know I'm starting at 0. Okay, so that's how long it takes to make one cycle, right? Now, what I'm going to do is to find theta, I'm going to do the inverse of cos. So cos inverse of √3 on 2. But the problem is there's going to be many answers to cos inverse of √3 on 2. Okay? Now before I write out my answers, let's figure out where is cos √3 on 2. So again, let's ask the right questions here. We say, what does cos represent again? It represents the x values. So you look at the x-axis. This is where positive x is. That's where negative x is. Now, √3 on 2, I don't know where it is, but I'm just going to guess it's a bit more than half. So let's say here. Okay, let's say √3 on 2 is here. And if √3 on 2 is there, this is what we have. We've got root 3 on 2, that's where x is root 3 on 2. The question is, where around the unit circle will you have an x coordinate of root 3 and 2? They're the only two places where you have x being root 3 and 2 is here and there. These are the only two spots where the x coordinate would be root 3 and 2. Right, so I'm going to put in the dots. The only two spots that you could have is right here. That's the only time you have an x coordinate that is root 3 on 2, and this x coordinate is root 3 on 2. We don't care what the y is. Okay, we're more interested in the x. So that means those are the two spots I want. Okay, those are the two spots. Now, the only thing you really need to know is your exact values. What's the angle? So what angle would I need to have a distance of root 3 and 2? That's what you're asking. You're saying, what should the angle be? So cos of what angle gives you a distance of root 3 and 2? So go back to the exact values. Cos of what angle? 60. Not 60. Cos of 60 is half? 30. The angle 30, okay?
Oh, cos is on that side.
Yeah. So I know that these two are 30 degrees. So now I can work with it. Let's start at 0. I start at 0 degrees. Let's work through the unit circle. So here we go. I'm going to go around the circle. I keep moving and I hit my first solution. How did I hit my first solution? I went from 0, add another 30 degrees, and I get to my first solution. So that's what I'm going to write down. I'm going to write, okay, it's 0 plus 30 degrees. That will give me my first solution, because I know at 30 degrees, I will get x equal to root 3 on 2. Then from there, after I get my solution, I continue around the circle. So I keep going and going and going. I'm not hitting any. No root 3s on 2s right now. It's all negatives. All the x values are negative right now. And then it's -1, and it keeps going. It gets smaller and smaller and smaller, and then x equals 0 here. And then I keep going. Okay, now it's in the positive region. And finally, I hit my next solution here. But I know it's easier to calculate this blue entire angle if I know the full circle's 360 degrees. Take away 30. That's much easier. True? Okay, so I'd say since that's 30 degrees here, then 360 is full revolution. Take away 30. And that's how I get my next solution. I say, all right, well, before I finish at 360 degrees, I know it was just short of 360 by 30. And I started at 0 and I ended up at 360. I finished my one revolution. So my answers are 30 degrees and 330 degrees. So what does this mean? What does it mean when you have these answers? What does it mean? It just means you found out cos of what angles will give you root 3 and 2. So if I type in the CAS right now, I did cos of 30 degrees, it should give me root 3 and 2. Okay. That's what I know. I know that if I did cos of 30 degrees, it should give me root 3 and 2. Okay? And same thing with 330, it should give me the same answer as well. Now, if you do this in your CAS, please be careful the mode that you're in. So if you look at the mode up here, that's in radians. So that means the angle that you put in is in radians. You've got to make sure it's in degrees if you want to change it to degrees. Okay? Now, see if I did cos of 30, you watch, it doesn't equal to what I want it to equal to. It's not root 3 and 2. Okay? You have to change your settings, or you could do this. If you don't want to change your settings from radians to degrees, if you're a bit lazy on it, you can do cos 30. Now, in your button, down at pi, can you see, if you click on that pi button is the degrees here. You can put the degree symbol after the 30. And if you do that, cos of 30 degrees, root 3 and 2. Okay? Alternatively, if you were too lazy to type in the degrees part, then yes, you could do cos of 30, but you just have to be careful with the settings. So if you change the settings, document settings, okay, so if you press document settings, and you change the angle to degrees, then it also works as well. Okay? Now in methods, we work with radians. Okay, we work with radians. So I like to keep that as radians. and I would rather put in a degree symbol to get exactly the same answer. Okay, that's what I would do. Okay, that's what I would do. Now, while we're on the topic of calculators, I'm going to teach you how to use the CAS to solve for 14H, because we're going to do it again tomorrow, just in case you're having troubles to know if you're doing it right. Check with the CAS as well. Okay, so this is how we do it. We wanted to solve for this. We wanted to solve, how do we do cos of an angle equals to root 3 on 2, right? We had a domain which is 0 to 360. This is what I'm going to get you to do on your CAS. Okay, so on your CAS, we're going to do menu, 3, solve. So throughout the year, I've been teaching you solve, right? Solve. We're going to do cos. Go to Triggs. Lauren, Finn, I'm teaching CAS. Be great if you're watching or doing. Here we go. Cos. So I'm going to do cos. Instead of doing theta, I like to use x. It's just easier to type. So I do cos of x. So x is an angle. I want it to equal to root 3 on 2. So control divide gives me a fraction. Control x squared gives me the square root. So root 3 on 2. I do comma x. Now, if you do this, I'll make it larger so you can see. If I type this into the calculator and I say solve for x, it won't give you an answer. The reason why is because it doesn't have how many revolutions. It assumes that there are infinite solutions or infinite revolutions. So you have to tell it a domain. You have to tell it where you're starting and where you're finishing. So in this case here, x, how do you tell it a domain? So last session or last term's unit, you had to learn how to put in a domain. I'll show you how to do it. Go to control, equals, you get a vertical line here. Okay, so you get a vertical line, put in the vertical line, that means given. So now I want to let them know there's a condition here. The condition is x on the outside of the bracket. Very good. Outside of the bracket. I want x to be larger than 0 or equal to 0, and I also want it to be less than 360. You don't need to put in the degrees. If you just say 0 to 360, they'll be able to calculate that for you. Okay? So I'm going to keep my settings in radians. All right, here we go. If we press enter. Oh, sorry, it's in. I just changed it to radians. That's why. Whoops.
So we should put in degrees.
Yeah.
Degrees.
Yeah. Delete. Oh. All right, I'll type this again, and I'll delete this one. Okay. Put in the degrees. Again, if you can't be bothered putting in the degrees, if you change your mode to degrees, it would work it out for you. Okay? This is in radians as my answer for 11 pi on 6. 11 pi on 6 because I put my mode in radians. If you want it in degrees, if you want to know the answer in degrees, okay, you would go to change my documents, I'll change my settings. 2 degrees, and watch if I do this now. See, the mode will change what your answers would be. So depending if you want it in degrees, guys, talk some other time. You got after class, you got Facebook, whatever it is, do that afterwards. You don't have to do it in class while I'm explaining as well. I don't understand that. You got your solve for cos. That's exactly what we've just been doing by hand. This is how to do it by CAS. So I put in condition 0 to 360 degrees. This is the only difference between the two is when I change my mode to radians, it gives me answers in radians. If you change your mode to degrees, then it gives you an answer in degrees. Okay, so depending on what the problem is, most problems and methods is in radians. That's why I want you to memorize or learn how to use radians instead of degrees. Okay. But that's what we'll be doing tomorrow's session as well, and I'll go through the second, how to use a CAS, window adjustments, zoom bots, how to fix your window settings, in case you haven't been practicing that, because you'll need that for circular functions. It's going to be really tricky to sketch circular functions. You have to know how to zoom in and move out the functions. Find the x-axis intercepts, intersections. Okay, but that's how you solve for 14H. All right, I'll leave it there. That's 14H. We're going to just leave it there. And I want you to practice. I'm going to show you which questions to practice first. Just do, which one? Okay, I just want you to do for this session, tomorrow we'll do 2, but I want you to do question 1 and question 3. Because I just shown you how to do it when you do 2 revolutions 0 to 4 pi. And I've also shown you how to do it with degrees. Okay, so getting your answers in degrees. And then check your answers with a CAS. Okay, so you can check your answers with a CAS for both of them. Okay, so I want you to do it by hand, and I also want you to solve it afterwards. We haven't touched on dilations, so when I change to 2x, at the moment that's what I want to do. Tomorrow's lesson I'll teach you how to do it when it's 2x. Sine of 2x equals to half. How do you do that? What's the difference if the period changes? Okay, so if the period's not 2 pi, what if it was pi? How do we do that? Okay? There you go. Question 1 and 3. Have a go with question 1 and 3 for this session.